this problem from continuity of function, and the problem is, let fx, this is step function x square sin pi x, this is also known as box x square sin pi x, x greater than 0. Then 4 options are given. Okay. Here the given 4 options are most confusing. Now we test the problem for this 4 options. We first take x greater than 0 but x belongs to z, and in this case x, this is equal to n, we let, and we know that x square, this is equal to n square, belongs to z also, and box n square is discontinuous. But sin n pi at that point of x, sin n pi, this is equal to 0. So fx must be continuous at x equal to n belongs to z. Okay. So we can delete the option the f is discontinuous everywhere. This is not correct. Now we take a point x, this is of type root 2 or root 3 or root 5, etc. Okay. Here x square, this is equal to 2, that is box x square, this is equal to box 2. This is not continuous. We know that box function is not continuous when x is integer. Okay, so this is not continuous, and sine root 2 into pi, this is not equal to 0. So box x square into sine pi x is not continuous at x equal to root 2. Okay, so this option is also not correct. F is continuous everywhere. This is also not correct. Now we take a point which is not perfect square. Here it is given that the function is continuous only those points which are perfect square. We take a point which is not perfect square. Let x, this is equal to 1.5. Obviously this is not perfect square. Now x square, this is equal to 2.25 because 1.5 whole square, this is 2.25, and box of this, this is obviously 2, and this is also continuous because this is fraction, not integer. And also sine pi into 1.5, this is sine pi into 15 by 10, this is sine 3 by 2 pi, this is equal to -1. So the total function box x square into sine pi x is continuous at x equal to 1.5, but x equal to 1.5 is not perfect square. Okay, so this option is also not correct, right? Now f is continuous only at those points which are not perfect square, and this is I said this is not perfect square, but this is given that they are perfect square, so this is not correct, which is not perfect square. But we already proved in the in the first case, when x is any integer, that is, if we take x, this is equal to 2, at that point the function is continuous. Okay, but x equal to 2, this is not perfect square. Okay, and this is contradictory statement of this. Here it is given that the function is continuous only if the term only is not given in this option, then it is perfectly right. Okay. Now we have to choose any one of the 4 options. So we choose here option number C. Okay. This is not perfectly right, but deleting the term only, this is alright option. Okay. So here we choose the option number C. This is correct option. Otherwise all the 3 options are